Okay, now on the second part, which is on the OEL. Okay, because some of you already text me require further explanation on OEL. Okay, for this OEL, okay, yang ni saya ambil daripada Word punya dokumen Okay, so giving in this task over here, okay, you need to design a converter. Okay, this converter will be used for driving an electric vehicle. So if let's say that I think for the electric vehicle, there are many types of DC to DC converter that been using. Ada yang guna bi-directional, which is that one is isolated DC to DC converter, which is different type of converter. Okay, my suggestion is that try to find a data sheet with regards to either buck boost or buck boost converter. Okay. Which is the non-isolated DC to DC converter. Alright, okay. So in this task over here, okay, the converter must be designed such that its input voltage can vary within minimum and maximum value. So which is dekat sini, your VS is varied. Okay, you will have VS is vary, and then it mentioned here your output voltage pun akan vary juga, which is your R lah basically. Okay, your output voltage ni, okay, input voltage normally in the data sheet dia akan specify what is the minimum and maximum rated of the input voltage. Okay, for the output voltage, if let's say that in the data sheet it only specify let's say one output power P0 voltage lah pula. Okay, one output power P0. Okay, so you use that as a guide, and then you try to katalah awak dapat in the data sheet your P output power will be equals to 200 watt contoh. Okay, you try to like make vary, let's say 100, which is the minimum from the rated value, or maybe you can try this is normally this is the rated value. So the rated value more or less it will akan berada dekat tengah-tengah dalam range So you can so it will be plus minus. So katalah your output power yang you get from the data sheet is 200. So you can vary this data output power over here. Let's say from this is okay 100 to 200 watt, ataupun 200 to 300 watt, ataupun 150 kita ambil tengah-tengah to 200 watt. Okay, so this is like a guide, so you can vary input voltage, kena betul-betul ikut dekat yang mana kat dalam data sheet lah. And kalau boleh ambil yang output power dia maintain the same regardless of the variation of the output power or variation of the input voltage. Right. Okay, and then apa lagi dia mention? Okay, inside here it says that the converter must operate in two mode, which is in CCM and DCM. So you need to show that two mode over here, which is with regards to waveform. Okay, and then in finding the L, the value of inductor, okay, kita akan guna, you need to use two approach. One is that your L is 25% greater than L min. Okay, the second approach is delta IL is 40% of your average inductor current. Kena guna dua-dua approach Kalau guna satu saja approach, maka pun kita potong juga. Okay, alright. Okay, and then what else? Okay, you can use either MATLAB or PC. Okay, and then in order for you to produce the waveform, okay, kalau boleh saya nak awak zoom in into 2 cycle punya waveform, right? Okay, since dekat sini awak pakai your switching frequency. Okay, switching frequency is not being mentioned here, so you can use any type of switching frequency. So you can refer to the lecture notes. So switching frequency must be at least 20 kilohertz in order to avoid audio noise. And then you can range up to 1 megahertz. So boleh gunalah any value of switching frequency, should be no problem. Okay. Right. So, okay, ni saya dah keluarkan I highlight what are the things that needed in order to answer for this OEL. Okay. Find datasheet. Okay, you need to make sure that you have a variation of input voltage. Okay, the output power, which is you will have two value of your R and two value of your input voltage kat sini Okay, Vs min and Vs max. Okay, for the L, you need to use two approach. Okay, this is the first approach and this is the second approach. Okay, and then you need to, the converter is able to operate in CCM and DCM. So depending on the value of L lah. So awak kena vary. So let's say waveform with regard to CCM first, and then you change the value of L to make it the converter operate in DCM, and then you display the waveform. Okay, and then okay, other parameter, switching frequency ke, output voltage ripple. Okay, yang tu you boleh assume or you boleh select any value Okay, untuk output voltage ripple, okay, normally kita akan select less than 5% lah. So you can select 1% ke, 2% ke, 3% ke. It depends. Okay, it's up to you. Right. And then what I need is that nanti kita akan tengok dia punya verification with regards to the theoretical and simulation results. So I need to check whether the one that you calculated, does it match with your simulation waveform and value. Okay. Okay, this is the OEL data collection sheet. Mana sekejap. Okay. Nanti saya share kat dalam Google Classroom. Okay. Okay, basically, okay, just a guide for you you nak buat different pada ni pun tak ada masalah. Okay. Boleh nampak tak ni? Can you see this?
Nampak.
Alright. Okay. Okay, yang ni nanti saya share kat dalam Google Classroom so that it will help you in finding the necessary parameter. Okay, in this, okay, kita ada dua table ni. Okay, this is table for the first approach here. Alright. And also the second table for the, oops. Okay, and the second table over here. Right. So, kat sini, okay, saya mention, okay, VS, which is you have what we call your minimum and maximum input voltage, P out. So kita ada this kind of combination. So your output voltage maintain the same. So using these two VS and P out, you will get, so you can put the value of your duty cycle. And this is the calculated R. Okay, and then using the first approach, L min. Okay, so L min, if let's say that you are using buck converter, boost converter and buck boost, obviously you will get different value of L min, and different value of data sheet will get different value of L and C. So as long as you follow the same equation, which is if let's say that your converter data sheet kata that is buck, you need to use the buck equation. So if let's say that your data sheet is boost, you need to use boost equation, or if let's say that the data sheet is buck boost, use buck boost equation. So far I haven't covered buck boost yet. Inshallah by this weekend, I will upload the video with the lecture with regards to buck boost, so you can watch and have a look, and we can discuss it maybe next week after your test lah. Alright. Oh, nanti kita announce as a test pula. Okay. Okay, and then the second table over here using the second approach. Okay, so you can refer to this. Okay, and then okay, kat sini okay, select the highest L min and value of C using the first approach. So since kita akan ada 4 value of L min, so you choose the highest one. Okay, you multiply by 25%, which is 1.25, you will get X. Okay, whatever value lah. Okay, and then also what are the value of C that you are selecting? Okay, letak juga dekat sini. Okay, pilih one value saja. Right, okay, and then using the second approach, okay, okay, choose whatever value that you already calculated here. Alamak, saya sepatutnya letak okay, nanti saya masukkan untuk second table ni tak ada column untuk L. Okay, nanti saya masukkan. Okay, okay, so from the second table, okay, you choose the highest L, which is equals to Y ke apa ke. Okay, and what are the value of C that you're going to use. Alright, so using these two L, the selected L and C, yang tu yang nilai yang awak akan masukkan dalam you punya circuit. Okay, ni which is kita akan vary dekat sini lah. Yang ni yang saya akan verify you punya circuit lah. Alright, so L sama juga dengan X yang you select previously in the calculation table. Okay, and then so for this one, so the L here untuk the 4 row ni akan sama lah. Okay, tapi you punya IL, the one that you calculate, the one that you get from your simulation circuit, you substitute inside here. And same goes to IL max, IL min, and also capacitor kita akan select, you akan select lah yang mana kita select previously. Okay, so kita akan view that. Okay, and then we need to confirm if let's say that katalah your output voltage from the data sheet you should get 12 volt. So I need to see whether did you get 12 volt actually. Okay, and then this is using the first approach. The second table over here using the second approach. Okay, L goes to Y. So Y ni akan sama saja for the 4 row. Okay, nanti yang akan berbeza adalah your IL max, IL min. Okay, right, and then from these two table over here, okay, these two table untuk CCM for DCM, okay, okay, for DCM, okay, you can choose any value of L as long as it less than L min. Okay, and then but you need to show it display the waveform in DCM. Okay, and write what are the value that you are selecting in the answer line over there. Okay, and then for DCM, I think same goes to for the CCM. You need to produce this kind of waveform over here. Okay, waveform of IL, VL, V0, I switch, I diode, and I not in CCM and DCM, and then you can compare lah, and then you can comment and write a discussion with for that. Okay. Alright. Okay. So that one is with regards to the circuit construction and verification. Okay, this one over here with regards to the report writing. Okay, report writing, you need to refer to the OEL template. And ni saya dah post, I think last week code. Okay, so do refer on the template. It's like a paper format form, a conference paper format form. Okay, right. So these are the criteria that I will be looking on once I mark the report. Okay, there is you can refer to appendix 1, which is there is a rubric on how what are the criteria that will be assessed in order to get that kind of marks. All right. So for the what we call the report, we have introduction 10%, background theory 15%. Okay, background theory no need to be that details. Okay, as long as you explain the operation of the converter. Okay, what else? Maybe what are the equation that the theoretical equation that been using, and maybe what else? Maybe the design consideration in designing a DC to DC converter. Yang tu boleh masuk dalam background theory. Okay, on introduction you can select where normally this DC converter being applied and what is the importance of having a DC to DC converter. Okay, for stage 1 and stage 2, stage 1 kita ada design circuit, operation and design procedure. So basically I would like to see how you construct the circuit, which is what are the steps involved in constructing the circuit, and how you display your waveform. Okay, and then and how good in terms of displaying the waveform. Okay, kalau MATLAB tu saya tak nak background hitam. Okay, saya nak background putih, so you need to edit. I think I did teach in the lab session. Cumanya I'm not too sure whether for lab session on Wednesday and Thursday I did enter your lab ke tak. Tak apa, you can refer to the one that have a lab session on Tuesday and Wednesday. Okay. Alright. What else? Okay, untuk stage number 2, which is on the simulation result and discussion. So from all the waveform that you already produce, generate in CCM and in DCM. So you need to comment and write, compare with the theoretical value. And if let's say that it's not the same, why is that it's not the same, right? So you can write down what are the reasons. Okay, and it should be the same, but sometimes it might not be the same due to setting of the software ke apa ke. So you need to, or maybe you calculate wrongly ke. So that is the things that you need to find out. Okay, okay, all your calculation ni nanti masukkan dalam calculation yang teori ni, masuk dalam stage 1 ya. Okay, sebab nanti saya akan check using Excel each one of the value to make sure that that is the correct value. Okay. Right. What else? Okay. Last, the final one is on the conclusion and reference. So write a conclusion and what are the reference. So reference is basically the one that normally you will using in this introduction and background theory. Okay. And the format, if you follow the OEL template, you will get free 5%. Okay. And correct format ni maksudnya kalau katalah awak ada table, awak ada figure, you need to label the figure properly, you need to label the table properly. Okay, figure 1, figure 2, figure 3. Don't just put it a figure. Okay, refer to figure below. Yang tu memang tak dapat lah 5%. Okay. Right. So okay, good news. Okay, so the online submission saya extend sikit sampai lepas raya. Sebab I do understand you have FYP ETP presentation, ada yang ada FYP presentation, and then you have other tests as well. So saya akan extend sampai end of this month, which is 31st May. Tapi kalau lepas pada this ni, saya takkan late submission, saya akan penalize Alright. Okay, untuk circuit verification, so tadi kita nak, I want you to have the report in PDF format. Okay, for your circuit, yang ni you kena hantar in PC or MATLAB punya file. Okay, submit into the Google Classroom. Okay, and then, okay, dia punya file punya name tu, make sure, okay, letak awak punya nama. And also your matrix number. Kalau katalah your name is quite long, katalah Muhammad Nur Hakimi Firdaus ke whatever, okay, so you just put it a bit short. Tapi you punya matrix ID kena betul lah, matrix ID kena yang betul so that at least I can identify you using your matrix ID. Okay, alright. So I think that's it. Yeah, that's it for the my presentation. So is there any question? So I can happy to answer all the question. Ada soalan?
Doktor nak tanya tentang cari data sheet. Sebabkan soalan dia tak mention apa part yang dalam electrical vehicle. Saya boleh cari data sheet yang berkaitan dengan contohnya suspension system, ABS system.
Yes, can. Sebab itulah I make it general, sebab I know kalau kita specific on what are the things in electric vehicle, so it will limit you punya searching for data sheet. So that's why I make it general so that you can mana-mana type as long as it's in the electric vehicle, tak ada masalah. Lagi?
Okey, faham. Terima kasih.
Okay.
Puan, boleh tak
Okay.
I sebab I dapat punya graph sangat pelik. Dia ada triangle sikit, lepas tu dia bawah tu dia macam satu baris macam pelik.
Yang tu which is a straight line yang satu baris tu is it a straight line lah kan? A DC line kan?
So
you-
I sharekan I punya slide bagi puan tengok.
Boleh.
Okay. Okay, puan nampak tak skrin ni? Ayo,
Sekejap.
dah lari dah.
Oh, okay. Yang
Dah lari. Sekejap.
okay, this is apa the
Atas tu adalah
load current voltage apa ni?
Yang ni voltage je. I buka word sebab yang ni dia hang dah. Dia
Oh, dah
punya kan. I punya mail dah hang dah.
Oh, ya ke? Okay. Sekejap.
I buka word sini. Okay,
Aha.
sini I ada try banyak value lah. Okay, yang
Okay.
untuk ada satu punya dia dapat macam ni. Dia punya atas tu adalah low voltage.
Dia macam ada okay ni. This one is voltage kan?
Yang ni untuk voltage ni yang bawah. Ada punya cantik tapi tapi dia banyak, dia macam ni.
Kalau by theory you akan dapat macam normally square kan? Tapi you dapat just like
dia dapat
trapezium
square.
kan? Yang ni dah discontinuous mana tadi?
Ni.
Cepat sangat lah Wan. Okay, yang ni okay. This one
Tapi
is okay.
Sebab I kira dengan Excel tau, tapi value dia semua pelik-pelik ya. Dia punya value resistor semua sangat rendah.
Datasheet apa yang you pakai?
I pakai datasheet.
Memang maksudnya kalau kata from the datasheet
I pakai datasheet ni.
dapat R berapa?
R tu I dapat jika ikut dia punya tu.
Oh, dia punya output current tinggi kan?
Output current dia 100.
20 M. That's why lah awak dapat. Sebab tu dah dapat R kecil.
I try cari banyak tapi dia punya R kan semua memang kecil sangat yang tengok ni. Semua sangat yang dapat graph yang cantik pun ke tak cantik pun resistor dia value sangat kecil.
Oh, yes, tak. Sebab you punya output current is quite high, 20 M. Tapi dia punya voltage rendah saja. That's why lah awak dapat R awak kecil.
Tu I won't.
Okay, maybe okay. Tapi kalau compare dengan simulation, okay tak? I mean like the value, is it the same or is it different?
Simulation, sebab simulations tu dia punya tu kan I guna ni, dia punya simulations tu kita patut dapat 5 volt kan, dia punya simulation voltage pun rendah sikit. Dia pun rendah sikit.
Tu rendah banyak tu, kalau 5 volt 4.3 tu.
I pun tak tahu sebab yang duty cycle resistor semua I dah ikut masuk dah. Ada punya dapat tapi ada punya memang rendah macam ni. I no idea. Tapi circuit ni I dah proof dah dengan yang internet I tengok kat video punya I masukkan value dia, memang I dah proof circuit ni dah betul dah.
No, circuit memang betul tapi tengok from the data sheet tadi dia kata the output voltage that you should get is 20 M tapi you dapat 17.3 je kan?
Ya, I pun tak tahu.
So a bit rendah sikit lah.
Kenapa ya? Dia dapat 70. Memang rendah gila.
Kan, so macam like 3 M missing lah kan?
So
that's why yang you punya output voltage pun tak dapat 5 volt. Sepatutnya you dapat 5 volt kan?
I try data lain, dia punya ampere pun sangat susah nak dapatkan dia punya output current.
Output current? No, tak apa. Kalau data sheet tu tak ada output current tak ada masalah. As long as ada dia punya input voltage, ada output power, then should be okay. Jadi tak semestinya once kalau katalah awak ada you punya input voltage and you punya power, so it does sufficient enough to prove that yang you get from the actual data. So all yang the rest tu you just refer from your calculation lah. Maksudnya your simulation tu refer daripada calculation yang awak dapat using the equation.
Oh. Macam ni jika based on current side kan? Yang current side. Current side macam ni betul tak? Yang first tu adalah inductor current.
It looks okay. Yeah, the shape looks okay. Value tu, yang ni awak guna the first approach ke L equals to 25% greater than L min?
Betul. Yang first approach tu, yang untuk CCM dulu.
Sebab tu lah you can see that kalau you tengok dia punya minimum and maximum inductor current it very quite high kan, daripada I think 0 point something sampai tak nampak lah sebenarnya. Maksimum dia tak nampak. 0.1.
Yang sini adalah minimum. Sini adalah sini minimum, sini yang darab 1.25.
Yalah, okay. It looks okay. The shape looks okay. Sebab tu lah, macam Philips tanya kat sini, what is the difference between first approach and second approach? Both consideration. Okay. Different between the first approach and second approach ni, basically, kalau kita guna dua approach, there is no problem using both approach. Both approach are acceptable. The first approach yang kita pakai L equals to 25% greater than L min. Bila kita pakai that this approach over here, normally you will have a huge range of your inductor current, which is you punya variation from minimum to maximum inductor current tu agak tinggi. So that's why that is one of the difference lah. And then untuk the using the second approach, which is kita pakai delta IL tu, delta IL is 40% of average inductor current. If we are using that approach, normally the amount of the variation of the minimal and maximum inductor current a bit small. So which is it will lead to a more stable output current. Yang tu guna the second approach. Tapi that's why I cakap dia banyak trade off. Tapi if you are using the first approach, normally value of your inductor a bit smaller than using the second approach, which is it will lead you to a better efficiency. Sebab losses dia a bit small. So it's I would say a trade off lah. Dia ada win dekat sini, ada lose dekat sini. So but there is no problem. So that's why you can tengok using both approach, what are the difference. You can identify lah apa using the you can compare between first and second approach and identify what are the different. Let's say in terms of what called variation of your inductor current, the value of your inductor, the value of your capacitor. So those are the things that you can look into and write a discussion with regards to using this both approach. Apa dia? Okay, sangat faham. So we must use yes. Guna dua approach and then you come up with the waveform lah. Tips for apa lagi? Operation komputer. Apa ni?
Puan, untuk yang DCM kan, kita assume satu value of inductor, lepas tu kita terbalik calculate macam ni lah.
Yeah. As long as it's less than L min lah. So ambil lah macam katalah try lah 20% less than L min ke, 30% less than L min ke, ataupun 40% less than L min ke. At least bagi nampak dia punya ada part discontinuous tu nampak clear. Kalau katalah you pakai kalau katalah pakai 10% less than L min, mungkin awak akan nampak dia punya discontinuous part tu a bit small je duration. At least boleh nampak yang kita boleh nampak yang part discontinuous tu banyak lah juga. So saya nak bagi nampak, kalau boleh nampak 3 mode tu bila switch on, and then bila switch off and bila switch and diode off. So 3 mode tu boleh nampak clear.
So Elmin tu maksud kita ambil dari yang CCM punya.
Yes. And then
Oh.
try smaller, katalah Elmin yang dapat katalah 20 microhenry. Try lah 10 milli and 10 milli lah. 10 micro and C, 5 micro and C. Macam mana waveform dia tu tengok.
Okay, faham. Terima kasih.
Okay, untuk next week kita ada test, online test. Okay, there will be one question. Duration is 1 hour. So it will be at your home. Okay, 3 to 4. Okay, and then we will have about 30 minutes for you to upload the answer. After 30 minutes, I will not accept anymore. Okay, tips. Tengku saya ni tanya pasal tips So satu soalan DC to DC converter. So currently I did cover for 2 type of converter, which is buck and boost converter. So salah satulah kita keluar sama ada buck atau boost. So buck boost, so far saya tak upload lagi nota, so it will be unfair lah for you. Kalau saya tak upload lagi nota, saya tanya soalan tu, kan? So at least, okay, so please study on buck and boost converter. So revise balik all the exercise and example that have been given in the lecture note, as well as during this live session, so that you be able to understand how buck and boost operate and what are the difference between these two. Alright. Okay. Apa lagi? Anything else? Ada apa lagi pertanyaan? What time is now? Okay. Ada apa lagi nak tanya?
Doktor.
Ya. Ya, Mahmud.
Doktor boleh share ke yang presentation doktor rekod Sebab
Boleh.
tadi suara kadang-kadang tak jelas lah tadi.
Okay, boleh saya kejap lagi saya share kat dalam Google Classroom. Yang last week punya saya tak share sebabnya record tu start dah middle of the presentation dah. So saya rasa macam nanti susah lah awak nak follow, sebab tu lah saya tak share tu. Tapi kalau nak share juga yang last week punya boleh je. Ada lagi? Pasal OEL ada apa nak tanya?
Puan, yang kalau datasheet tu saya dapat yang itu power output tu dia tak satu value saja. So kalau nak dapat dia maximum dan minimum, so kita kena buat macam mana?
Kalau tadi kan, kalau kata dia dapat satu saja value, let's say from the datasheet katalah 500 watt. Kan?
Boleh
So
ambil 100 ke 150 lah.
Ambil lah a bit range, katalah tolak 100 ke tolak 150 watt, from 500 tambah ke, you play around sikit lah with the value.
Okay, terima kasih Puan.
Okay. Lagi? Anything else?